In this class, I will explain about force couple system. So in the last video, we learned about what is a couple, what are the effects of a couple, and characteristics of a couple. Now, in some cases, in some problems, we have to transfer a force acting at a point to some other point within the plane. For example, here this is a rod where a force P is acting at A. Now I want to transfer this force P into point B without changing the external effect of the force acting on the rod. So external effect should remain the same, but instead of this force P acting at A, I have to transfer that force P to point B. Now how to do that? So when you transfer a force acting at a point to some other point within the plane, then that force will be transformed into a force and a couple. That is why the word force couple system. Force acting at a point can be transformed into a force couple system acting at some other point in the plane. So that means if you are transferring this force P acting at A to point B, then at point B you will be having a force as well as a couple. Now let us see how we can transform the force at A to a force couple system at B. Now in this case, first step what we have to do is, whatever direction of force is there at A, you introduce the same force at B in the same direction. This is the first step. Then what happens? Since I have introduced a new force at B, the value of that force is P in the same direction as that of A. Now the effect on this rod will change. To neutralize the effect, what we have to do is, to nullify the effect, I have to introduce another force P downwards at B of same magnitude but acting in opposite direction. You can see here. Now if you observe, this force is acting upwards, same amount of magnitude of force is acting downwards, and these two forces are collinear, something like this, collinear. Then what happens? The effect of this and this will cancel. So this force tries to pull the rod in this direction, whereas this force tries to pull the rod in this direction. Since the forces magnitudes are equal, so the rod remains at the same position. So that means after introducing this force P, so this and this, they nullify the effect and this will remain same. So without changing the effect of this force P, I have introduced this. So first step, I have introduced the same force in the same direction at B. Then I have second step, I have introduced a force P in the opposite direction and collinear. Please note that it is collinear also. So this force P is introduced in the opposite direction as well as it will be collinear. Now what I will do here is, now I will combine this force and this force. So if you combine those two forces like this, P separated by distance D, now what happens, according to the definition of a couple, so these two form equal, opposite, parallel forces separated by distance D. That means this gives a couple of magnitude P into D. So this can be replaced, these two forces can be replaced by a couple of magnitude P into D, and of course it is clockwise force. You can see here, the effect of both these two forces is to rotate this rod in the clockwise direction. That means these two can be replaced by a couple of magnitude P into D. So I can write like this now, AB, this force P will be there, this force P and this force P, that can be replaced by a couple of magnitude P into D in the clockwise sense. That means now what we have done here is whatever force is there at A, that force P, now it is replaced by a force P in the same direction and a clockwise couple at B. What you can say here is, if at all you are transferring a force acting at a point, if you want to transfer that force to some other point in the same plane, you will get an additional couple acting at that point. So this is known as transformation of a force into a force couple system. Now I will take an example for this, numerical example. Of course, I will take an inclined rod. AB is an inclined rod. Length of this rod may be 4 meters, and the angle is 30 degrees, let us say. It's an inclined rod, angle is 30 degrees, length is 4 meters, length of this rod. Now I will take a force acting here at some angle. In last class I have explained how to calculate the moment of inclined force acting on an inclined rod. So this angle I will take it as 30 degrees, 50 Newton. A force of 50 Newton is acting at B at an angle of 30 degrees to the axis of the rod. So this is the axis of rod. Now I want to transfer this force B into a force couple system at A. So the question is, transform the force of 50 Newton at B into a force couple system at A. So this force has to be transferred here, but as we know from this concept, this force will lead to a couple also here. Now the procedure will be like this. What I have done here, same force in the same direction I have applied, so that's what I have to do there also. Now if you are transferring to B, it will be like this. AB is the rod, distance is 4 meters, and this angle is 30 degrees. So what I do here is, this force I will transfer to A in the same direction. So that means this should make an angle of 30 degrees only, and the force is 50 Newton only. See what I have done here, same thing I have done here. Now in addition to that, you will be having a moment acting here. Now how to calculate that moment? Actually this whatever couple you are going to get, P into D, that is nothing but the moment acting at B or acting at A, because the effect of a couple remains same in the plane. That's what I have told in the characteristics of couple. We have discussed that in the last video. So P into D, this couple effect will be same whether it acts here or here or here or here. Or in other words, if you find this value of MA, that is the moment at A, that moment at A itself is the magnitude of the couple. So that couple will be calculated by taking moment at A. Moment at A is calculated by resolving this force. So I have explained that in the last video. So what happens if you resolve this 50 Newton force, horizontal component, global horizontal component will be this, vertical component will be this. So this is your x-axis, y-axis, global x and y-axis. Since this is 30, this is also 30. This total angle becomes 60. Then this horizontal component will be 50 cos 60. Vertical component will be 50 sin 60. So in other words, we have to calculate the moments of this 50 cos 60 and 50 sin 60 about the point A. So that gives the value of MA. That itself is the couple. Now let us calculate that in this diagram. So here, if you take this as AB, if you draw the perpendicular here, and if you take this as C, so at B you have horizontal as well as vertical force. Horizontal is 50 cos 60, vertical is 50 sin 60. Now I use these two distances. So this distance and this distance, because if you are calculating the moment about A, moment of this 50 cos 60 will be 50 cos 60 into this distance. So line of action if we extend that, so 50 cos 60 into this distance gives the clockwise moment, and this 50 sin 60 into this distance, this horizontal distance, that gives the anti-clockwise moment due to this. So last problem also we have done with similar lines. Same procedure I am following here. So this I will take it as x, this I will take it as y. This is 4 meters we have given, and this angle is 30 degrees. Now what is the value of x? X will be 4 cos 30, or cos 30 will be x divided by 4. Y will be 4 sin 30. Now let us calculate these two values. So 4 into cos 30, it will be 3.464 meter. 4 into sin 30, of course it is 2 meters. Sin 30 is half. Now therefore, if you are calculating moment at A, which is nothing but MA, that itself is the couple. So MA is equal to taking clockwise positive and anti-clockwise negative. So moment due to this force, 50 cos 60 force will be, it is clockwise about A. So therefore it is plus 50 cos 60 multiplied by distance is y now. So this distance, so y is 2 meters here into 2. Then moment due to this will be anti-clockwise about A, minus 50 sin 60 into x. Distance is x. X is 3.464 meter. So 3.464. Now this is the value of the moment at A due to both the forces. So let me calculate it. So 50 into cos 60. Cos 60 is half. It becomes 25. 25 into 2 will be 50 only. Minus 50 sin 60. 50 into sin 60 into 3.464. So the answer is 149.99. You can take it as 150. So that means minus 100 Newton meter. Please note that it is moment force into distance. So you are getting negative value means it is anti-clockwise, because we have assumed clockwise positive in the sign convention. So moment at A becomes minus 100 Newton meter. That means what I can say now, so whatever value of MA is there, it is anti-clockwise here, and its value is 150 Newton meter. So that means this is the couple. So that is why it is called as force couple system. So the force at V is transformed to a force and a couple at A. So whatever couple you are going to calculate, that is nothing but the moment at that point. So this is how we have to compute, or we have to analyze a problem when a force is given at a point, and when we are asked to transform that force into a force couple system acting at some other point. Let me take another example, because this is very important time. So another second example I will take. So you can have a rod like this. AB is the rod. Now C is a point here. So what I will do here is, I will take a force acting like this at B, 20 Newton, acting at 20 degrees. and the distances I give 1 meter, 2 meter. Now the question here is transform the force given at B to a force coupled system at A as well as at C. Force coupled system at A and C. That's what is there now. Now let us take first at point A. So we have, I will directly write here because already I have explained here neatly. Just in one step I will explain this. So let me transfer that B, force at B to force and couple at A. So B he has given a force like this. So same force we have to write here in the same direction, 20 Newton making an angle 20 degrees. Now couple I have to calculate. Couple is nothing but, it is nothing but MA. Taking clockwise positive. Now what I have to do? I have to resolve this into components. If you resolve that, horizontal component will be like this, vertical component will be like this. So this is 20 cos 20, this is 20 sin 20. Now moment due to these two forces is nothing but, I taken about point A is nothing but MA. So moment due to this 20 cos 20 is acting like this only. Therefore, moment is 0. Perpendicular distance is 0. The force is passing through that point A. Therefore, moment due to this 20 cos 20 will be 0. Because the force is passing through that point A. Perpendicular distance is 0. Whereas the moment due to this 20 sin 20, see here, it is giving a counterclockwise momentum, anti-clockwise momentum about point A. So minus 20 sin 20 into distance. Distance is perpendicular distance, which is 1 plus 2, 3 meters. Distance we have to measure from point A. Now this first expression is 0. Second expression is minus. So 20 into sin 20 into 3. 20.52 minus 20.52 Newton meter. So this is negative, therefore it is anti-clockwise. That means I have to introduce an anti-clockwise couple here, which is 20.52 Newton meter. So this is how we can transform the force acting at B to a force coupled system acting at A. Now I will take the second point C. He has asked at C also. Same procedure is followed. The only thing is here, I don't want A now, C and B. So here also, if you are transferring this B to C, I have to introduce the same force, 20 kilonewton, acting at 20 degrees. Same force I have to introduce. Now I have to calculate MC now, moment at C, taking clockwise positive, similar lines. So here also, the moment of this 20 cos 20 about C will be 0 because that is passing through C. So 20 cos 20 into 0. Moment of this is anti-clockwise, so minus 20 sin 20. The distance is 2 meters. From C we have to take the distance. So first value is 0. Second value is minus 20 sin 20 into 2. So 20 into sin 20 into 2, which is 1.368. So it is negative minus 13.68 Newton meter. Once again, this is anti-clockwise, negative, anti-clockwise. So you have to represent an anti-clockwise couple here acting at C, whose magnitude is 13.68 Newton meter. So you need not write negative minus there because minus indicates that the sense is anti-clockwise. So this is how you can find out or you can transform force acting at a point to any other point within the plane. The thing is, the force gets converted to a force and a couple. So that couple is calculated by taking the momentum of the force, given force, about the point where we have to shift that force. So that is, here I have shifted at point A, here I have shifted at point C. So this is an important topic, how to transform a force into a force couple system.